Welcome to The Explainer. Today, we're diving into the story behind the single biggest breakthrough in modern AI, the tech that powers everything from ChatGPT to huge scientific discoveries. Yep, we're talking about the Transformer. So, have you ever wondered, when you ask an AI to write a poem or explain something complicated, how does it seem to just get what you're saying? Well, to figure that out, we actually need to rewind the clock a bit, back to a huge problem AI had to solve, just understanding the basics of human language. And this shows the problem perfectly. Just a few years ago, if you gave an AI a long sentence, it would kind of lose the plot. It would literally forget the beginning of the sentence by the time it got to the end. But now, it can translate really complex ideas almost perfectly. This explainer is all about how we made that incredible leap. Okay, let's get into it. To really get why the new stuff is so revolutionary, you have to understand the wall that researchers were hitting. We're talking the mid-2010s. AI was getting pretty good, but it was just really bad with language. So the first models that had any real success used something called an encoder-decoder architecture. The easiest way to think about it is like two people. The encoder is the person who reads a sentence in English, and the decoder is the person who listens to that and then writes out the new sentence in, say, German. Right, but here's the crucial point. These early models had a massive flaw. They tried to squish the entire meaning of a sentence, every single detail, into one tiny little piece of information called a context factor. Now, for a short sentence, that worked, okay. But for anything longer, details just got lost. It was a huge bottleneck. So this bottleneck problem, it forced researchers to come up with a really clever workaround. They realized, hey, what if the AI didn't have to summarize everything at once? What if it could just look back at the important parts when it needed to? This led to a breakthrough in 2015 that really started to crack the problem wide open. And that breakthrough was called the attention mechanism. I love this idea. It's like giving the AI a highlighter. So instead of trying to remember the whole sentence from that one little summary, the decoder could now look back at the original text and pay attention to the specific words it needed for each part of the translation. And this improved the quality a lot. But here's the catch. Even with this cool new attention superpower, the underlying process was still pretty old school. The AI still had to read the sentence one word at a time. This sequential process was a major roadblock. It meant training the models was super slow, and that stopped them from learning from the massive amounts of data they needed to get really smart. Okay, now let's jump to 2017, because this is where everything changes. A team of researchers published a paper that didn't just suggest an improvement to the old system. Nope, they threw the old system right out the window and started a revolution. The paper was called "Attention is All You Need." And that wasn't just a catchy title. It was a radical statement. They basically argued you could get rid of all the slow sequential parts of the model and build something way faster and more powerful using nothing but that attention mechanism. And this timeline really shows you just how fast things were moving. I mean, think about it. We go from a clunky system in 2014 to a clever little fix in 2015 to a complete and total revolution just 2 years later. That's an incredibly fast evolution. And this is the fundamental shift that made everything else possible. Instead of that slow, single-file line of words, transformers created a multi-lane superhighway for data. They could process all the words in a document at the exact same time. This parallel processing wasn't just a little speed boost. It was the key that unlocked the ability to train AI on the massive scale of the entire internet. This revolution in speed wasn't just about making things faster. It was about making things possible that were completely science fiction before. This new architecture unlocked a whole set of superpowers that really define modern AI as we know it today. And here are those advantages. Because they train so fast, they're incredibly scalable. You can just throw unbelievable amounts of data at them. They're also flexible enough to handle not just text, but images and sound too. But maybe their most important superpower is this thing called transfer learning. This concept of transfer learning is a total game changer. Here's how it works. First, you spend a ton of time and money pre-training a gigantic model on, the whole internet. It learns grammar, facts, reasoning, everything. Then you can take that giant pre-trained brain and quickly fine-tune it on a much smaller, specific data set, say a bunch of legal documents, to create a specialized expert AI. It means you don't have to start from scratch every single time. So, why does all this techie detail matter to you?
Well, because this architecture isn't just sitting in some research lab, it has totally exploded into our daily lives, powering some of the most famous tools on the planet.
I mean, you've definitely heard of this one. ChatGPT. The T stands for transformer. It's a generative pre-trained transformer. It's right there in the name. It's that powerful chatbot that can write essays, poetry, and even code, all built on this foundation.
Or what about this? DALL-E 2 is another transformer-based model. But instead of writing text, it takes your text descriptions and turns them into these incredible, complex, and sometimes pretty weird images.
And then there's this, which is just a massive breakthrough for science. AlphaFold 2 uses transformers to predict the 3D structure of proteins, a problem that stumped biologists for like 50 years. So when you look at all of these together, you can really see just how versatile this one core idea is. From creative writing, to art, to solving these fundamental scientific challenges, the transformer architecture is just unbelievably adaptable. But of course, this kind of incredible power doesn't come for free. The rise of transformers has also created a new set of very serious challenges, and it's shaping the entire road ahead for AI development. Yeah, the key thing to note here is that these models are not easy to build or run. They're incredibly expensive, they need huge server farms, which has a real environmental cost. And because they're so ridiculously complex, it's often impossible to understand why they make the decisions they do. That's the classic black box problem. So because of those challenges, the future of this whole field is really focused on making these models better. Researchers are working hard to make them more efficient, more transparent, and less biased. We're also seeing this push towards specialized models, like a doctor GPT or a legal GPT, and of course, expanding their power to more languages all over the world. So it's pretty wild, right? What started as a clever solution to a technical problem in machine translation has completely reshaped our world and given us these tools of incredible power. The story of the transformer really leaves us with a huge question for the future. Now that we have this technology, what are the most important problems we should be using it to solve?